Hello everyone, this is Praveen Sunhare. Today, in this video, I am going to tell you about WSN topologies. Before moving into the main topic WSN topologies, let me give you a quick recap on what is WSN. So, WSN is a wireless sensor network that can be defined as a network of devices that can communicate the information gathered from a monitored field through wireless links. It means in a wireless sensor network, we have a monitored access through which we can gather the information via wireless link. In WSN, data is forwarded through multiple nodes, and with a gateway, the data is connected to other networks like wireless Ethernet. It is a wireless network that consists of base stations and number of nodes, that is wireless sensors. It will be more clear by looking into the diagram. Here in this diagram we have data acquisition network, data distribution network, in which machine monitoring, animal monitoring, vehicle monitoring, medical monitoring, all are wireless sensors, and base station is also there. Now, what is topology? Topology is an arrangement with which the computer and network devices are connected to each other, which means all the computers and other network devices, when they are connected to each other, and thus there is an arrangement, and that is referred to as topology. The arrangement can be actual and logical. The network structure of wireless network is not limited to one design. While designing the network, the developer has several choices of topologies for configuring the network. Following are the different topologies. The topologies are bus, tree, star, ring, mesh, circular, and grid topology. Now let us discuss each topology one by one. First is bus topology. Bus topology is easy to install. In this type of topology, congestion of traffic and single path communication is there. Such kind of topology work best with a limited number of nodes. If nodes increased, performance problem may occur. The diagram of bus topology is shown in the figure. Second one is tree topology. Tree topology use a central hub called root node as a main communication router, and this central hub is one level below from root node. In sensor network, path may be single hop or multi-hop. It finds an optimal shortest tree with maximum lifetime and shorter delay. High time complexity and more suitable for distributed implementation. Load balancing problem at each level of fat tree. There is a disadvantage of tree topology. If there is a link break in the unipath on the active route, then communication may also break. The diagram of tree topology is illustrated in the diagram. Now, topology is star topology. This kind of topology connects to a centralized communication hub, commonly known as SYNC. Nodes do not communicate directly. It means the node can communicate indirectly. Here, entire communication must be routed through centralized hub. Each node is then a client, while the central hub is a server or sink as shown in the diagram. The drawback of star topology is there can be a single path communication. Now next topology is ring topology. In ring topology, every nodes have exactly two neighbors. In this type of topology, the entire messages travels through a ring in the same direction. That is, the message can travel either in the clockwise direction or in the anti-clockwise direction, but not simultaneously in both the direction. Failure in the node breaks the loop and can take the entire network. There is a benefit of such kind of topology is that it can control the congestion of traffic and double path communication. Then mesh topology. Mesh topology involves message which can take any of the several paths from source to destination. A mesh network in which every node connects to every other is called a full mesh. There is also a partial mesh network which can exist among those nodes which are indirectly connected. The diagram is shown. Now next is circular topology. Circular topology. In circular topology, there is a circular sensing area, and that the sensing area has a sink at the center. The sensor nodes sense the event of interest and transmit this data to the sink. The nodes are centrally deployed with uniform density all around the sink, as illustrated in the diagram. Such kind of topology are easy to establish, easy to maintain, and more efficient. Now, next type of topology is grid topology. Here the sensor network field divided into grids. Network area is partitioned into non-overlapping square grid with the same size. At least one and only one node in working state in each grid at any time. The network lifetime can be extended when the nodes in a grid should work in turn. Inside each grid, one node is selected as a grid head which is responsible for forwarding, routing information and transmitting data packets. Routing is performed in a grid by grid manner. Grid-based multipath routing protocol intended to route packets fast, utilize and extend sensor nodes energy in addition to avoiding and handling network congestion when happens in the network. The diagram of grid topology is shown in the figure. There is a special kind of topology which is known as two-tier hierarchical cluster topology. This is the most common architecture for larger wireless sensor network. In this topology, nodes within a specific region send their data to a local cluster head. In turn, all such cluster heads from different regions send their collected data to the gateway. This network can be interlaced further also, that is, the cluster head of tier 2 can send the data to the cluster head of another network, which can further send the data to the gateway. The biggest advantage of such kind of topology is that it divides the whole network into a number of small zones within which routing of signals can be done locally. The cluster heads can be designed to be more powerful in terms of computation and communication. In addition to this, the nodes can also be connected through a wire, which increases the transmission speed as well as the reliability of the network. At last, there is a comparison chart of various kind of topologies on the basis of the factor performance. And the factors are path, node failure, load balance, congestion in path of the packets, packet reception ratio, energy consumption, network lifetime, reliability, which we can illustrate on the basis of this comparison chart. Thank you for watching and have a nice day.